Hello friends, in this lecture I would like to explain design of beams based on the steel structures. See here an ISWB 300 at the 481 Newton per meter acts as simply supported beam with an effective span of 6 meters. Calculate the design strength of beam. Assume Fe250 grade steel and also the beam is laterally supported. So here the meaning laterally supported indicates the compression flange is restrained from buckling, and at the same time they can mention one property which is ISWB. So what is ISWB? It indicates IS indicates Indian standard and WB indicates wide flange beam. Okay, so there will be some standard properties in the steel code book and also in the IS 800 code book. I will show you the properties. So first take down the given data, that is ISWB 300, which is acts at a simply supported beam with an effective span of 6 meters. So they are asking to calculate the design strength of the beam. Okay, and they are also given some assume the data which is Fe 250 means Fi equal to 250, that is yield stress. Okay, so first check the formula in the code book. So that was in page number 59. See here, page number 59, they will given about the shear. So Vd equal to design shear strength. So write down this formula first and then choose what are the properties required for ISM WB 300 in the code book or steel book. So Vd will be equal to Vn by gamma m naught. So I am taking the same formula here. Vd will be equal to Vn by gamma m naught. And again gamma m naught partial safety factor against shear failure. We can see that value in 5.4.1. I will check that one also later. First, Vn will be equal to Vp, and again Vp will be equal to AV Fi by Fiw by root 3. Fi in the sense Fiw same. Okay, Vn will be equal to Vp, and again what is given the formula here? Vp will be equal to AV Fi by root 3. See, this is the formula which is given in the code book. See here, Vd will be equal to Vn. Again, in place of N, I am taking Vp because Vn will be equal to Vp, which is gamma m naught. And again, in place of Vp, I am taking this formula, substituting the value here. AV Fi by root 3 into this gamma m naught. Okay. See here, the design strength of the formula you can remember directly like this also. Fi AV by root 3 gamma m naught. Okay. So for finding gamma m naught, we can check in the code book which is 5.4.1. I will go to that page directly. See here, this is 5.4.1 design strength. For that there will be one table for finding partial safety factor. So resistance governed by yielding, resistance of member to buckling. So the partial safety factor will be here, that is 1.10. So we are in this condition which is 1.10. Actually there is only one condition, that is restraint from buckling, resistance governed by yielding and resistance or member to buckling both will be 1.10 only, and resistance governed by ultimate stress is given means you can take 1.25, and again bolt and fabrications you can take these values which is 1.25, and later for welds you will get 1.50. So here your partial safety factor will be 1.10, this value will be 1.10. And again, what about this AV? See in the same code book, page number 50. So here AV will be equal to H into TW. Again, hot rolled or welded. See here in the code book, if you see in the steel tables, ISMB, ISWB 300. Here there will be ISWB 300 and we are choosing steel beams, rolled steel beams. Therefore, you can also choose here AV will be equal to H into TW. This AV will be equal to H into TW. If you are taking welded means you can take D into TW. But we are choosing rolled beams. Therefore, H into TW. So take down that formula directly. H into TW into Fi. This Fi indicates this 250 value by root 3 into gamma m naught. Next, see the properties in the steel table. What are the properties given? So that is in page number 4, the steel table, ISWB 400. See here this one. Sorry, 300, ISWB 300. So ISWB 300 will be here. So the value will be given 66.7 kg per meter. Here the value is 48.1. Sorry, here ISWB 300, which is this line, totally this line. So I am shading that line here. Okay. ISWB 300, the weight will be 48.1, sectional area will be 61.33, depth of the section H will be equal to 300, width of the flange 200, thickness of the flange 10.0, thickness of the web 7.4, IXX will be equal to 9821.6. But actually, what we required according to the formula, just we required H value, thickness of the flange, thickness of the web. Okay, that two will be enough. Check that one. Thickness of the flange will be equal to 10.0 and thickness of the web will be 7.4 and H value will be equal to 300. So only these two values will be required as per ISWB 300. So this is the basic questions which generally get in the diploma level. So H value will be equal to 300 and thickness of the web will be 7.4 and remaining values you will get 250 by root 3. Gamma will be 1.10. So if you simplify this one, directly you will get 291.29 kilonewtons. So like this you have to find the design strength based on the steel tables directly. Okay. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.